Here I will explain analysis of two-stage RC coupled transistor amplifier. Analysis of two-stage transistor RC coupled amplifier. That means determination of voltage gain for mid-frequency range. In that analysis, determination of voltage gain in mid-frequency range. Comma, voltage gain in low frequency range, in low frequency as well as high frequency range. High frequency range. And finally determine lower cutoff frequency and upper cutoff frequency. Lower cutoff and upper cutoff frequency. And upper cutoff frequency. First of all, have to draw the two-stage RC coupled amplifier. This one is a transistor, stage 1, RE. CE. R1, R2, RC. Stage 2. This is the stage 2. RE, CE. Similar stages. R1, R2. A coupling capacitor. Here, coupling capacitor CC is used to connect the stage 1 and stage 2. This one is RC. Plus VCC. Output is taken across this one. This is the Vout. Source, voltage source in series with resistance is to be amplified, connected here. This is the circuit diagram. First of all, you have to replace this circuit diagram two-stage RC coupled amplifier with the H parameter model. Stage 1, approximated H parameter model is used to replace this above circuit. We use approximated H parameter model. Approximated H parameter model. For stage 1, this one is a base collector and emitter. For stage 1, one is base. The approximated H parameter model base. HIE. Only HIE and HFE is there. This is the transistor is in common emitter configuration. IB current here and For stage 1, HFE IB. HFE IB. This is the load resistance RL. This is one is also load resistance RL. Here two biasing resistances R1 and R2 is connected to base and collector. Two biasing resistance. Here need not consider here at the input side. Load resistance is the load resistance. RL is connected between this is the C terminal, C collector terminal. This is for first stage. Only HI and HFE is there. Approximated H parameter model is used for this transistor one. This is the load resistance. VCC is equal to 0. For AC analysis, DC plus VCC is equal to 0. VCC is equal to 0 means this RL is connected between collector and ground. Therefore, this RL is connected between collector and ground. And coupling capacitor is also there. This is the coupling capacitor. CC is connected to CC is connected to second stage with the first stage. Here biasing resistances. Here biasing resistances R1 because VCC is equal to 0. R1 is connected between this this terminal base and this is the base and emitter, and R2 is also connected here. R1, R2, and input resistance of that stage 2 is Ra2. This one is Ra2. R8. R8 is connected here. R8. This one is to this one emitter 1. This one is emitter 2. This is the stage 1. Stage 1. This is the stage 1 and stage 2. Stage 1 and stage 2 both are connected by using some coupling capacitor. By using coupling capacitor here, R1, R2 and Ra2, that is Ra dash. Ra2 is also HIE of the second transistor. Therefore, Ra dash is equal to R1 parallel to R2 parallel to HIE. Finally, Ra dash is approximately equal to HIE. All are connected here. The parallel combination. This is the parallel combination. This is Ra dash. Therefore, Ra dash is approximately equal to HIE. Finally, the circuit is replaced with here base emitter HIE. This one is base current IB. HFE IB. HFE IB. This one is a load resistance RL and coupling capacitor CC. This one is Ra dash is replaced with simply HIE. Simply HIE. This is the output V out and V in. Voltage gain for mid frequency range. First one is a voltage gain for mid frequency range. Mid frequency range. At mid frequency range, the reactance or impedance offered by this coupling capacitor C is so small that it cannot be effectively considered. The effect of CC is not considered at mid frequency range. Therefore, CC is replaced by short circuit. This one is after circuit diagram is like that. Base, emitter, HIE, IB. This one is V in, HFE, IB, RL. CC is not considered. CC is acts as short circuit. At mid frequency range, the impedance offered by the coupling capacitor CC is so small that it can be effectively considered as short circuit. This is short circuit and HIE V out, HIE V out. Therefore, mid frequency range AM gain in mid frequency range V out by V in, V out by V in. This is the current source in parallel with RL. Current source in parallel with any resistance is replaced with voltage source in series with resistance. This one is HIE, base, emitter, IB, V. This is the direction is from top to bottom. Therefore, we use minus plus HFE IB into RL. This series resistance RL is in series. This current source and HFE IB value, current source value is HFE IB and RL. These two are connected in parallel. This parallel combination is replaced with voltage source in series with resistance. That is, voltage source value is HF current source into load resistance, current source value into load resistance. That means HFE IB into RL and RL. This one is HIE, HIE. This one is V out. V out. According to voltage division rule, V out is equal to, this is minus plus sign, minus HFE IB RL, this voltage source value into HIE into HIE by sum of these two resistances RL plus HIE, RL plus HIE. This is this voltage source is replaced with suppose plus minus HFE IB RL. That is the reason we use minus sign. Minus HFE IB RL into this resistance HIE by sum of these two resistances. Next one, V in is equal to, at the input side, V in is equal to IB into HIE, IB into HIE. Therefore, voltage gain AM at mid frequency range is equal to AM is equal to V out by V in, V out by V in. V out is equal to minus HFE IB RL HIE by RL plus HIE, and V in is equal to IB into HIE, IB into HIE. IB is cancelled, HIE is cancelled. Therefore, voltage gain at mid frequency range is given by minus HFE RL by RL plus HIE, RL plus HIE. This is the AM mid frequency voltage gain for mid frequency range of that two-stage transistor RC coupled amplifier. Mod AM is equal to mod HFE RL by RL plus HI. Therefore, magnitude term AM is equal to HFE RL by RL plus HI. Next, voltage gain for low frequency range. Next, voltage gain for low frequency range. It is represented by AL. That is AL. In the low frequency range, the reactance of the coupling capacitor C must be included. The shunt capacitor, however, can be neglected to be in an given circuit. Only coupling capacitor is considered at low frequency. Draw the circuit diagram. This one is HIE, V in, IB, HFE, IB, RL. This one is RL. CC, coupling capacitor CC is included. And shunt capacitor effects is negligible at low frequency range. This one is HIE. This one is HIE. V out. This one is a V out. Current source in parallel with RL is replaced with voltage source in series with resistance. Therefore, HIE base, this one is emitter, AB, this one is V in, this one is plus minus HFE, IB, RL. This one is CC value minus 1 by J omega CC, 1 by J omega. Reactance of that coupling capacitor is 1 by J omega CC, must included in the low frequency range. In mid frequency range, it is not included. It acts as short circuit. This one is V out. This one is V out. Apply voltage division rule again. According to voltage division rule, V out is equal to total voltage applied to the circuit is minus HFE IB RL into HIE, because V out is across HIE. That is the reason multiply here HIE by sum of these three resistances, RL plus HIE plus 1 by J omega CC, coupling capacitor. Therefore, V in is equal to here, V in is equal to IB into HIE. IB into HIE. Therefore, low frequency range gain AL is equal to V out by V in, minus HFE IB RL into HIE by RL plus HIE by HIE minus J by omega CC. V in is IB into HIE. HIE is cancelled. IB is cancelled. Therefore, AL is equal to minus HFE RL by RL plus HIE minus J by omega CC. Mod AL is equal to magnitude of that low frequency voltage gain AL is equal to, due to that modulus, mod H minus HFERL is HFERL by, this is the real term, this one is imaginary term, square root of RL plus HIE whole square plus 1 by omega CC whole square. This one is magnitude term. One is frequency response. Frequency response of that RC coupled amplifier here is here F mod A. Mod A is the gain of that magnitude of that two-stage. Magnitude gain of that two-stage RC coupled amplifier mod A. Its mid frequency range it is AM. In a low frequency range that is here AM by root 2 that is AL. AM by root that is AL. This is the low frequency FL. Now I have to derive this FL. We know that two expressions mod AL is equal, this is the mod AL, mod AM by root. Okay, mod AL is equal to HFE RL by square root of RL plus HIE whole square plus 1 by omega is equal to 2 pi F CC whole square. We know that AM is equal to mod AM is equal to already derived that expression HIE RL by HIE plus RL. Yet F is equal to FL. Yet F is equal to FL. Mod AL is equal to AM by root 2. Mod AL is equal to AM by root 2. Mod AL is equal to AM by root 2. Okay. Mod AL is equal to mod AL is equal to AM by mod AM by root 2. Mid frequency gain by root 2. Mod AL is HFE RL by square root of RL plus HIE whole square plus 1 by 2 pi F CC whole square is equal to mod AM. Mod AM means HFE RL by HIE plus RL into 1 by root 2. The common term is here is the common term here HFE RL is cancelled. Here 1 by RL plus HIE. Spare term is common here into 1 plus 1 by 2 pi. Here F is FL. At F is equal to FL. 2 pi FL CC into RL plus HIE whole square under root, total root is equal to 1 by root HIE plus RL. That is equal, this value is 1 by RL plus HIE and the square root of 1 plus 1 by 2 pi FL CC into RL plus HIE whole square. That is 1 by root 2 RL plus HIE. These two are cancelled. Therefore, finally root 2 is equal to square root of 1 plus 1 by 2 pi FL CC to RL plus HIE whole square is equal to root. Squaring on both sides, that is equal to 1 plus 1 by 2 pi FL CC RL plus HIE whole square is equal to 2. 2 minus 1. 2 minus 1 is equal to 1. 1 by 2 pi FL CC into RL to HIE root 1. Square is in this side, we converted into root 1. Therefore, root 1 is equal to 1. Root 1 is equal to 1. From this expression, FL is equal to 1 by 2 pi CC RL plus HIE. RL plus HIE. This is the lower cutoff frequency. Lower cutoff frequency FL is equal to 1 by 2 pi. FL is equal to 1 by 2 pi CC coupling capacitor CC RL plus HIE. RL plus HIE. In case of sometimes the biasing resistance of that second stage is also given. RI dash is equal to R1 parallel to R2 parallel to HIE. So if these two resistance are neglected, the Ri dash is HIE. Suppose these two resistance values are given in the examination problems. 2 pi CC RL, instead of HIE we use Ri dash. These two resistance value, biasing resistance values are given in that problem. We use this expression, coupling capacitor. Coupling capacitor affects the low frequency range. Next one is high frequency voltage gain for high frequency range. Voltage gain for high frequency range. We need to draw the at high frequency range. This is the transistor. Some wiring capacitances and transistor stray capacitors are included. This one is, these are the capacitances. C is not, C is acts as short circuit. Some capacitance, shunt capacitance are like that. CW1. This is the V output. CW2 wiring capacitances. This is the base conductor. This one is emitter. CBC capacitance. C C, CE, and this one is base C, B, E capacitance. These are the capacitance are play an important role. Total capacitance are treated as one capacitance that is included here. Model is like that. This one is base emitter IB HIE HFE IB RL. Coupling capacitor acts as short circuit, not play an important role. High frequency range. This one is HIE. All the capacitance are included here. That is CD. Shunt capacitance or stray capacitance or wiring capacitance affects the high frequency response of that amplifier to stage RC coupled amplifier using transistor. This is V out. This is V out. Simplify this model. This one is V in. Find out the high frequency gain. This one is simplified diagram. HIE, BE. This one is IB. HFE, IB. HFE, IB. RL. HIE. 1 by J omega CD. This one is V out. Apply. This is the single node circuit and one current source is there. That current source is equal to the current flow through this RL is V out by RL. The current flow through this HIE is V out by HIE. The current flow through this capacitance is ICD is equal to V out by 1 by J omega CD. Therefore, this one is IL. This one is IX. This one is IY. The algebraic, the sum of the currents are equal to 0. Means IL plus IX plus IY plus HFE IB is equal to 0. IL is equal to V out. V out by this one is V in. This one is V in. IL is equal to V out by RL. IX is equal to V out by HIE. IY is equal to V out by, because all are connected in parallel, the voltage across the all the parallel resistance are equal to V out. V out by 1 by J omega CD is equal to minus HFE into IB. Minus HFE into IB. So V out is equal to V out into 1 by RL plus 1 by HIE plus J omega CD minus HFE IB. Minus HFE IB. Therefore, find out V out. V out is equal to minus HFE IB RL into HIE by RL plus HIE plus J omega CD into HI, RL into HI. This is V out. Next, V in is equal to, we know that V in is equal to IB into HI, IB into HI, high frequency range, voltage gain for high frequency range of that two-stage RC coupled amplifier using transistor. V out by V in, V out by V in. V out is minus HFE IB RL HIE by RL plus HIE plus J omega CD RL HIE, and V in is IB into HIE. This IB is cancelled. HIE is cancelled. Therefore, finally, V out is equal to AH is equal to minus HFE RL by RL plus HIE plus J omega CD into RL HIE. Magnitude term AH is equal to HFE RL by square root of RL plus HIE whole square. Omega is equal to 2 pi f CD RL HIE whole square. This is the mod AH. Again, frequency response. This is the response F mod A. This is mod AM. This is mod AM. Mod AM by root 2. Mod AM by root 2 here is we can consider FH. This is the mod AH. Mod AH. Mod AH. Mod AM by root 2. Mod AM by root 2. We know that mod AH is equal to HFE RL by HFE RL by square root of RL plus HIE whole square. 2 pi F is FH. At F equal to FH. At F equal to FH only, mod AH is equal to mod AM by root 2. 2 pi FH CD HIE RL whole square. Mod AM is equal to 1 by, this one is 1 by root 2. This one is 1 by root 2. HFE RL and HFE RL is cancelled. Therefore, common term this one is 1 by RL plus HIE 1 plus 2 pi FH CD HIE RL by RL plus HIE whole square under root. So the root that is equal to 1 by root 2 into 1 by HIE plus RL. These two are cancelled. Therefore, squaring on both sides. Squaring on both sides means root 2 whole square is 2. This square and square term is cancelled. Square and root term is cancelled. Therefore, 1 plus 2 pi FH CD HIE RL by RL plus HIE whole square. That is equal to 2 pi FH CD HIE RL by RL plus HIE is equal to 2 minus 1. 2 minus 1, that is equal to 1. Therefore, 2 pi FH CD HIE RL by RL plus HIE is equal to root 1, that is equal to 1. Finally, FH is equal to RL plus HIE plus RL by 2 pi CD HIE into R. This is the upper cutoff frequency. CD is play an important role. Shunt capacitance or stake capacitance. This one is the total analysis. Mod AM with frequency voltage gain is equal to, we know that mid frequency voltage gain already derived, that value is HFERL by HIE plus RL. Mod AL is equal to low frequency range HFERL by square root of HIE plus RL whole square plus 1 by omega CC whole square. Next, mod AH is equal to square root of HFE RL by square root of RL plus HIE whole square plus omega CD HIE RL whole square. FL, lower cutoff frequency, FL is equal to lower cutoff frequency, FL is equal to 1 by 2 pi CC into RL plus HIE. Upper cutoff frequency, FH is equal to upper cutoff frequency, FH is equal to 1 by not 1 by HIE plus RL by 2 pi CD HIE into RL. Therefore, bandwidth is equal to bandwidth of the two-stage RC coupled amplifier is equal to FH minus FL. FH minus FL. The frequency response is like that. The frequency response gain versus mod A versus frequency. This is the mod AM. Mod AL is equal to mod AH is equal to mod AM by root 2. This one is this one, FL and FH. Therefore,